So this video is a review video of what we talked about yesterday. It's on grams to grams stoichiometry. Now, grams to grams stoichiometry is when we're given grams, that's what we're given the problem, and then we're asked to solve in grams also. Whenever you see that, these are going to be three-step problems. Always involve three steps. And the reason for that is if we just look at a basic equation for salt, this equation tells me that every time 2 moles of Na reacts with 1 mole of chlorine gas, you get 2 moles of NaCl. Those are amounts, but they are in moles. So I can only go from one substance to a completely different substance by using moles and using my coefficients to help me do that. Now, so if I'm given grams in the beginning, so if I was given, well, you have 15 grams of Na, how many grams of NaCl can be produced? I cannot do this with one step because what allows me to convert from Na to NaCl are these numbers here. And these numbers are in moles. So I have to be in moles of Na. If I'm given 15 grams, I have to find my moles first, right, of Na. That's my first step. Then I have to go, one step, I divide by my molar mass to get my moles of Na. Then that's my first step. My second step is I have to go from moles of Na that I calculated to moles of NaCl. And I do that by using the balanced equation. Alright, and then my last step, so that's my second step. Once I'm in moles of NaCl, I need to get 2 grams of NaCl by simply converting to grams, multiplying by the molar mass. So my first step over here, 15 grams, I need to divide by the molar mass. My second step, I have to go from moles of Na to moles of NaCl. That's when I use my balance equation. And then my third step is simply multiply by the molar mass of my new substance to get the grams of it. So it's 3-step problems. First step 1, step 3 is what we talked about in the last unit. Everybody did really well on that test. And the step 2 is the only new step that we've added in this unit here. So these are the steps. I would like someone to write these steps up on my board, the big whiteboard. That way you can see them every time. When you're going from grams to grams, these are the steps. If you notice, if we have one-step problems, if we're already in moles, then step 2 is what we've been doing, mole to mole stoichiometry. Moles to gram stoichiometry, if we're given moles in the beginning and asked to solve for grams, then we are doing step 1 and step 2. If we are given moles in the beginning, or if we're given moles in the beginning and asked to solve for grams, we're doing steps 2 and step 3. If we're given grams in the given and asked to solve for moles, we're doing steps 1 and 2. And then if we're given grams as in our given and asked to solve in grams, we're doing all 3 of these steps right here. So if they're on the board, that way you'll be able to see them. Every time you work a problem, you'll have the steps to go by that you can see. So look at an example. If we're given the equation Na2O plus H2O produces 2 moles of NaOH, how many grams of NaOH is produced from 60 grams of Na2O? So if I'm going to rewrite my balanced equation, it tells me that 1 mole of Na2O plus 1 mole of H2O produces 2 moles of NaOH. Now you can write this example wrong down if you like, or you can just watch this video. I just want to go back over this to make sure everybody understands. So those numbers are in moles, but I'm given, if I have 40 grams how many grams of NaOH is produced from 60 grams of Na2O? So I got 60 grams of this, and I want to go to grams of NaOH. I want to go to that. And like I said, it's going to be a three-step problem. Alright, I can't go from grams to grams. I have to be in moles before I can go from moles of Na2O to moles of NaOH. So my first step is going to be to convert to moles of what I'm given. I'm given 60 grams of Na2O. I want to divide by the molar mass of Na2O, which is 61.98. Around that's 2 decimal places, so it'll be 0.97. Now I'm in moles of Na2O. So my second step is going to be to go from moles of Na2O to moles of NaOH. I use that in my balanced equation for that. Now, my balanced equation tells me the coefficient for the Na2O is 1, so I put 1 over how many I actually have, which is 0.97. And I need to look for moles of NaOH. The coefficient for NaOH is 2. Put X. X is going to be my number of moles that of NaOH is what I'm calculating. And when I do that, I get 1X equals 0.97 times 2 is 1.94. Divide both sides by 1 and I get 1.94. Now I've just went from moles of Na2O to moles of NaOH. My last step is to convert to grams. I got 1.94 moles of NaOH. I want to multiply by the molar mass of NaOH, which I've already calculated to be 40.0. You'd have to find your molar mass. You have to add these up. I've already got them worked out. But 1.94 times 40.00 is going to convert that to grams of NaOH, which is what I need. And I get 77.6 grams of NaOH is my answer. Now when I look at this, what it's told me in the beginning, if I start off with 60 grams of Na2O, I should get 77.6 grams of NaOH. So if somebody gave me 60 grams of Na2O, said, hey, figure out theoretically how many grams of NaOH will be produced in this reaction, I could theoretically calculate on paper before we ever do the experiment to see. And the thing about it is, when you actually do the experiment, you'll never get this amount. This amount right here is what's called a theoretical yield. It's because in theory, this is if everything's perfect, this is what you should get, your theoretical yield. Your actual yield is what you produce in the lab, and you will never get that number right there because of human error. You'll lose a little bit of your reactant. You won't weigh it out exactly right. So you'll never get that amount. This is all theoretical stuff we're doing on paper. Now to look at another example, let's look at one more. We're given the equation 2Ga2, that's gallium oxide. So I'm going to rewrite that. Remember, 2 moles of gallium oxide. It breaks down into 4 moles of gallium and 3 moles of oxygen gas, which is O2. Alright, so what the problem is telling me is how many grams of oxygen. Grams of oxygen, I don't know what that is. And I'm given 15.3 grams of gallium oxide. I got 15.2 grams of this. Well, this is a 3-step problem. It is grams. So my first step is going to be to take my 15.2 grams of what I'm starting with of GA203 divided by the molar mass of GA203, which I've already calculated. I've already added those up. You got 2 galliums and 3 oxygens. Multiply by their atomic masses and add them up. Remember, I do not worry about this number here when I'm doing step 1. That's only used for step 3 when going from moles of GA203 to moles of O2. So I don't look at it when I figure out my molar mass. My molar mass was 187.44. And I get 0.0810. So that is moles of GA203. My second step, I need to go from moles. Now I'm in moles of GA203 to moles of what I want. I'm wanting grams of oxygen, so I need to first go to moles of oxygen. Alright, so in the balanced equation tells me that it's when 2 moles reacts, except I don't have 2 moles, I have 0.081 equals, I get 3 moles, so 3 goes on top, X, what I'm actually going to get, based on my only got 0.081 moles instead of 2. And I cross multiply, I get 2X is equal to those pies by 12 by 2. My X would be 0.12. Now I'm in moles of what I want. And what I wanted was oxygen. That's moles of O2. Now my third step is to simply convert my moles to grams by multiplying by the molar mass. It would be 0.2 times the molar mass of oxygen is 16.00. Since I have 2 oxygens, it will be 32.00. And I get 3.84. Now my answer would be grams of oxygen, which is O2. 3.84. So what the problem says, if I start off with 15.2 grams of gallium oxide, how many grams of oxygen would I get? Well, it would be 3.84. So stoichiometry is a way for me to, if I start off with a starting amount, how much of my product can be produced, and I weigh everything out in grams, because in the lab, it's what allows me to, our balances all weigh things in grams. They don't weigh things in moles. That's why we have to do conversions between moles and grams. And I can predict how much product will be formed from a starting, amount, or I can figure out, I got this much product, how much reactant do I need to get this amount? And that's what stoichiometry is.